Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter moving charges and magnetism. So any doubts if you have, then please write that in the comment section. We shall obviously clarify them in the subsequent videos. And also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that a strong magnetic field is applied on a stationary electron. Then the electron will remain stationary only. Since why the magnetic force, we know that the force due to a magnetic field that is given as q v cross b. So if the charge is having no, if the charged particle is having no velocity, it means that if v is 0, it means that if it is at rest, then the force will be also 0. The magnetic force on the charge, that will be also 0 only. So there will be no force acting, so it will remain at rest only. It will remain stationary. So option C is the correct answer. Here it is told two parallel wires in free space. Two parallel wires in free space are 10 centimeter apart. They are 10 centimeter apart and each carries a current I. Each carries a current I which is 10 ampere. The same direction also. The force exerted by one wire on the other per unit length. So that will be how much? So therefore the force will be, we know that it is equal to IL cross B. ILB it will be. Since the magnetic force it will be um, for this wire, let's say we tell this as the wire 1, the wire 2. So the force acting on the wire 2 due to the wire 1, the first we have to find the magnetic field which will be inwards here. The magnetic field will be equal to uh, mu naught I by 2 pi d, where d is 10 centimeter, mu naught I by 2 pi d, and then and we know that mu naught equals to 4 pi into 10 power minus 7 in the SI units. And so here the force acting will be IL cross B, L cross B. So the force will be toward the wire. We know that the parallel currents will attract and anti-parallel currents will repel. So here we have parallel currents. So parallel currents will attract each other. So the force on wire 2 due to wire 1, force on wire 2 due to wire 1 is ILB. So we have to find the force due to wire 1 per unit length. That will be equal to I into B. So that will be equal to mu naught I square by 2 pi d. So that will be, so mu naught by 2 pi, that will be equal to 2 into 10 power minus 7. So it is 2 into 10 power minus 7 into I is 10 ampere. So it is 10 into 10 divided by d. D is equal to 10 centimeters. So 10 into 10 power minus 2. So 10 and 10 which will cancel. So this will be 10 power 3. 10 power 3. So 2 into 10 power minus 4 Newton per meter. And it will be attractive. 2 into 10 power minus 4 Newton per meter, and it is attractive. So option A is the correct answer. Then here it is told that a toroid, we have a toroid. Toroid, toroid is somewhat like this. So here some wires are wound around it. So a toroid is acting like a twisted solenoid, and it has got n turns, and its inner radius is r1 and its outer radius is r2. It R2 is more than R1 obviously. If it carries certain steady current I current is flowing, the variation of the magnetic field due to the toroid with radial distance is correctly graphed in. So now we know that the magnetic field for R less than R1, the magnetic field will be 0, and for R greater than R1 but less than R2, the magnetic field will be mu naught into Ni, mu naught into Ni, where N is equal to number of turns per unit length. The number of turns N by the length is 2 pi R, and R is the mean radius. R is the average radius, means R is inner radius plus outer radius by 2. Therefore, N we can say that will be N by pi into R1 plus R2. So therefore, the magnetic field for R more than R1 but less than R2, that is mu naught Ni by pi into R1 plus R2. And for R greater than R2, the magnetic field will be 0. So therefore, the graph will be somewhat like option D, but here we should write R1 and R2 here. Then option D is the correct answer. Then here it is told tightly wound a, a tightly wound long solenoid has n turns per unit length. Tightly wound long solenoid is a solenoid. It has n turns per unit length and its radius is r, and it is carrying current I. A particle having charge q and mass m. So here is the, we can say it is the cross section of this solenoid. It is carrying current I, and a particle having charge q and mass m is projected from some point P on the axis. Here we have the axis of the solenoid. From here, the particle is having charge q and mass m. It has been projected from a point on the axis in a direction perpendicular to the axis. In a direction perpendicular to the axis. The maximum speed of the particle for which the particle does not strike the solenoid. So here it is told the particle should not strike the solenoid. So it means the radius of its circular path should be half of the radius of this solenoid. So therefore, we know that R equals to mv by qb. So here R is the radius of that circular path in the magnetic field. So here r should be equal to half of the radius of the solenoid. So then the velocity should be how much? And the magnetic field inside the solenoid will be uniform, and that is equal to mu naught into Ni. So therefore, mv by q mu naught into Ni, that is equal to r by 2. So we have to find out v. So v will be equal to, so this is the maximum speed. It will be mu naught Ni qr by 2m. Mu naught Ni qr by 2m. So option B is the correct answer. Here it is told which of the field pattern given below is valid for electric field as well as for magnetic field. So the first one, option A is applicable only for A and B. A and B, these two options, these two electric field lines patterns, these are applicable only for electric field, only for electric field lines. And option C, it is applicable for electric field as well as and for magnetic field also. Since why the option C use usually we know that the conservative electric field will not form closed loops. Conservative electric field can't form closed loops, closed loops. But non-conservative electric field can form closed loops. But non-conservative electric field, which which happens due to the electromagnetic induction, which happens due to the electromagnetic induction, which is called as the Faraday's law, which is due to the electromagnetic induction. It can form closed loops. So it can form closed loops. And magnetic field, we know that it can form closed loops. So it can be for non-conservative electric field and for magnetic field. And option A and B, these patterns of electric field lines are applicable only for conservative electric field. And option D is not neither applicable for electric field nor for magnetic field. Since why at a given point at the center here there are lots of directions which cannot happen. Since why the rule is that at a given point there should be a unique direction of the field. At a given point, the rule is that at a given point the direction the direction of the field should be unique. That means that option C is the correct answer. Then here it has been told that a metallic rod of mass per unit length 0.5 kg per meter, mass per unit length, that is mu, that is given as 0.5 kg per meter, is lying horizontally on a smooth inclined plane. So here we have a smooth inclined plane. So this is the inclined plane, and the wire is lying horizontally. like this. Here we have the wire, and this inclined plane makes an angle 30 degree with the horizontal, and then a magnetic field of strength 0.25 Tesla is acting on it in the vertical direction. It is acting in the vertical direction. When a current I is flowing through it, the rod is not allowed to slide down. The quantity of current that is required to keep the rod stationary is. So the rod will have mass mg. No, its weight will act mg, that is vertically downwards. And along the inclined plane, the the component of mg will be mg sine theta, where theta is equal to 30 degrees. And normal to the incline, the component of mg will be mg cos theta, and normal reaction will act. And then magnetic field is acting vertically upwards. So, and current is acting, and current is flowing horizontally. So I L cross B, L forces I L cross B. So the current should flow like this, not like this. The current, so this is the where the current should flow like this from here to here. So then the force will act, the magnetic force will be like this, I L L cross B. So it will act like this, the force which is I L B. And so the component of this magnetic force will act n- along the incline. This will be theta, which will be F cos theta, and this way it will be F sin theta. So it means the normal reaction that will act, that will be mg cos theta plus ILB plus ILB sin theta. Here the normal reaction is not asked, but here it is not sliding. So it means the net force up the incline should be equal to the net force which is down the incline. So therefore mg sin theta, that should be equal to F cos theta, which is ILB cos theta. Therefore the current I has been asked. So I will be equal to mg sin theta by LB cos theta. So this I can write, this is m by L, which is mass per unit length, which is mu, into G by B tan theta. Therefore, the current I, that will be equal to m by L, which is mu G by B tan theta. Mu G by B tan theta. So mu is 0.5. 0.5 into G is equal to 10 divided by B is 0.25 into tan theta, tan 30 degree, which is 1 by root 3. So this is 50, we can write, so 20 by root 3, which is approximately, can write 20 into root 3 divided by 3, which is approximately, okay, 20 into 1.732 divided by 3. So that is 34.64 divided by 3. So it is like 11.15. Yeah, 11.32. So 11.55 ampere. So 11.32 is the closest one. So option C will be the correct answer. So hope all of you have understood these solutions of these previous year KCT questions on the chapter moving charges and magnetism. Still, any doubts if you have, then please write that in the comments section. Uh, and please install our Sapiens education application where we shall upload some important homework questions based on the previous year KCT exam, which shall be obviously helpful for your exam. So thank you, everyone. Bye.